right, so at some point in your career, you probably have made a decision into what really makes you want to go to work each morning. And if not, that means that you're probably hitting the snooze button multiple times. And then, when you go to crank over your car and or push the button to start it, you're just like, do I really got to go to work? Well, for me, a long time ago, I went through and started to run some cable, started to get deep in the bowels of some of the Cisco operating system, learned all about networking, and fortunately for me, probably within about 2 years of doing all that, after some certifications and I figured out that I didn't really want to be a networking person. I didn't want to run cable up in attics. So for me, that was something that I made a decision on a long time ago. And, I went to where my roots are, and that's more of software engineering. And so I know enough to be dangerous about communications and network security. And specifically today, when we get in and start to talk about the network architecture and the networking components, it's really important here, especially with this domain, that you don't get overwhelmed. We're going to go in and talk about the OSI model, TCP/IP models, different protocols, what LANs are, what WANs are, different types of cabling, remote stuff, how to access things remotely, wireless technologies, and then we're going to talk about what the attackers do. And one thing is for sure, good morning, that cybersecurity is not a spectator sport. It's not. Whether you're in software or in cryptography or in communications of some kind, the world around us is continuously evolving. And, you can go a little while without staying up on the technical side of the house, but, hopefully you got some sort of tool and you're constantly sharpening the axe because, it's constantly changing. At least every couple of years, some new things coming out. But fundamentally, if you understand the roots of how things work, usually you can figure things out. And so that's what we're going to talk about today is, the network architecture and networking components. And so this is generally broken down into a couple of different things. We're going to start by talking about the network communication protocols. And so there's two primary ones that we'll focus on this morning. And one is this thing that's called the OSI model. And then the other one is this thing that's called the TCP/IP model. And so these two models are really what is the backbone of how networking and data has come to life. And why do I say that? I say that because the Open Systems Interconnection Reference Model is a way that we can use this abstract framework to communicate over the network. And so it was the way that it was explained to me many, many, many years ago is as follows. Let me put it into the chat window here. and see what your guys' thought process is for that. Does anyone hablas español? Oh, no. See? Okay. How about speaking de Deutsch? Sounds like you do a little bit there. All right. Parlez-vous français? Oh, oui. Anybody speak English? Yeah. So, that's funny. That's funny. No hablas. Yeah. And so the way that it was taught to me, and it really made sense, is that if we're going up in anywhere in the world and we're meeting people in in different countries, in order for us to establish communication, or in order for us to have a dialogue with people, at first we have to introduce what language we're going to speak. And so um, the International Standards Organization came up with this way that allowed all the different telecommunications to start putting together the way that we can actually, or we're supposed to talk in the early 1980s. And they came up with this thing that called the Open Systems Interconnection Reference Model. And really that was the backbone. The internet was starting to come to life, back then. I know, in the mid to late 80s, my sister used to love to talk on the phone. She's a little bit older than me, and she would take up the phone and always be contacting all sorts of girls and boys. And, I would need it for the internet. Like I would need to use the phone to dial up and use it for the internet. And so I would just take over the phone and use it all night, and she would always be pretty upset with us or with me. But in that time, it was just the basics, right? It was just being developed. We had bulletin board systems, and that's when it really was. This OSI model was starting to be utilized more and more. And then the TCP/IP model actually had its own model, and that's typically what is used today when we're examining and trying to understand any network issues. And so when we talk about these, I'm not going to spend a lot of time because it's implied that you kind of already know a lot of this stuff, but let's jump into it and at a high level start to talk about it. Let's go in and just first lay some groundwork. Okay. So first and foremost, the one thing that we want to jump into and talk about is this right here. Make sure that everybody understands that a protocol is equal to a rule. Protocol is equal to a rule. So whenever we say protocol, that's what we mean. We mean that we're using a rule and you have to follow the rule. If you don't follow the rule, you can't communicate over a specific or using a specific service. And so typically there's these things that are called services and the services run over ports. And so depending on what service you're running is directly related or tightly coupled, if you will, to what port you're running. And so if we're in networking, if we're using the specific rules, using the specific protocols, then we can run services over specific ports. And so people often, if you're not familiar with the way that the networking works, one of the easiest ways to think about it is if you're wanting to use a specific port, then it's kind of like the movie Monsters Inc. That's the way that I always think of it, because I'm a big animated movie kind of guy. Monsters Inc. If you recall, the they go into these doors, and each door has a kid that they're supposed to scare and whatever. Well, that's kind of what the ports are like. It's like going to a specific door and having the key to unlock that door because you're speaking the language of whatever door that is. So the port is like a door that needs to be opened in order for you to run the service on it. And so, we knock on the door. Maybe we have to authenticate sometimes to the door. Once we get through the door, then what are we authorized to see? But essentially, that's the way that at a super high level, it's kind of easily taught. And so when we jump into talking about this thing called the OSI model, there's going to be 7 layers of abstraction that you probably should already know. And there's different ways to know these, right? So at the top layer here, there's the application layer. Underneath it, there's presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical. And so what happens is, that's correct, we would use a couple of different processes that when you're using an app, whether it's on your phone or your laptop or whatever device you're communicating on, that app runs at the chair to keyboard transfer. So between you and the computing device is quote unquote the app that we use, right? And so the application layer has data that's associated with it. And with each movement from you, I'm going to draw you right here. That's right. I'm just going to draw you. There you go. Especially, since you've been hanging out with me for the entire week, you're super happy now because you feel confident you're going to pass the CISSP. At the top layer right here, the application layer, you start messing around with, I don't know, let's say TikTok right here with your cell phone. You're looking at it through the app. Underneath it, TikTok would need to present the data in some fashion, maybe, over a video of some kind. MP3, MP4, or MP4, or some other type of way that they deliver the video. Underneath it, they make sure that the session is stable. It keeps going down the stack, so it's still you're still watching this, and behind the scenes here, there's a whole bunch of things going on as the data is going from your cell phone all the way out to your wireless internet here. So your wireless device at your house, and then all the way over to TikTok servers, transmitting all the way over to TikTok servers, and then it would go up on the TikTok side to go and get the data over here. And this happens lickety split, super duper fast, where we don't even realize there's any latency behind the scenes. And so as it's going down, it's getting appended with data from each layer. It's getting appended. So the data set here, the packets behind the scenes here, are getting appended with each subsequent layer, with data from each layer. And so in order for us to do that, there are a whole bunch of things that are going on with protocols and rules. And usually there's services that run on both the lower layers, which is underneath here, and the higher layers. And so different people remember different ways to do this. There's a process over here, and I'm not going to spend much more time on this right here. I'm just going to show you. Brevity purposes, we're going to just draw something here, and we're going to say encapsulation. So this process over on the left-hand side is called encapsulation. Over on the right-hand side, it's called decapsulation. And one thing to think of here is when it's going from one device out to the medium, that's the communication medium, like the wireless device, or over 5G, or even on the Ethernet cable. It's going down the stack. That's called encapsulation. So it's going from layer 7 to layer 1, and then when it goes from layer 1 up to layer 7, it's called decapsulation. So check this out. If you typically will try to remember these, encapsulation, the encapsulation. So layer 7. Just bear with me if you already know this. There's some people that are have no idea what I'm even talking about. What we're going to do is we're going to do this right here. We'll give you a mnemonic way to remember it. All people seem to need Domino's pizza. So that's encapsulation. So layer 1, or layer 7 to layer 1. So as it's going down the stack, all would be application, people would be presentation, seam would be session, 2 would be transport, need would be network layer, data link layer would be Domino's, and then pizza. See how we did that? Whereas if we do it on the reverse side, the decapsulation, that would mean that we're going from layer 1 to layer 7. And because we have so many foodies on the horn here, on the call, it's important that we just stick to the food mnemonics here. We would start off with the presentation layer and the decapsulation, and I'll put it into the chat window here. Please do not throw sausage pizza away. So typically that's how people remember it, is if you're ever in a meeting and somebody's like, yo, I got this new layer 3 device, man, and it's the best thing since sliced bread. It only will cost you $150,000. Well, you're sitting there in the over on the other side of the table, you're like, layer 3? Okay. All people seem to need data processing. And you're counting it in your head, or you're like, please do not throw sausage pizza away. And, people absolutely do that. Oh, what is this? Really? Huh. I keep hearing about this Antico's Pizza. So I'm going to be over in Hotlanta on the 19th and the 20th. And I'm gonna have to check out Antico's Pizza. You ever been to Antico's Pizza? I ain't never even heard of it before. Apparently, it's got this big fancy name, Neapolitano or something. That sounds kind of fancy. So this is how it works, right? And that's how the OSI model works.